The third one is volume charge distribution, which is there in the nucleus. Now, in the linear charge distribution, there is a term linear charge density, which is charge per unit length. Second, surface charge density, which is charge per unit area. Third, volume charge density, which is charge per unit volume. Now, the question is, how can we find electric field due to these three distribution of charges? That cannot be calculated by Coulomb's law because that is for discrete charge like 1, 2, 3 charge. But here, so many charges are there. So, Gauss theorem will help us to find the electric field due to these continuous charge distributions. Gauss theorem states that the electric flux through any closed surface is equal to 1 by epsilon naught times the charge enclosed in that closed surface. Now, flux and closed surface, these are two new terms. In case of flux, there is one term area vector that we will discuss, and closed surface is a Gaussian surface that is also need to be discussed. That what is Gaussian surface? So, let's discuss these new terms. First, Gaussian surface is the surface which is a helper for us, which help us to apply Gauss theorem and to find electric field due to continuous charge distribution. Here are some properties of Gaussian surface. Most important properties are they can be of any shape and they should be closed and symmetrical. The any shape should be symmetrical. For then the area vector is nothing, just the outward perpendicular is the area vector, which is the direction of area, outward perpendicular, and any vector quantity can be written as area into magnitude into direction. Then flux is just the number of electric field lines crossing given area. Mathematically, flux is the dot product of electric field and area vector. Here, mm, units SI units are Newton meter square per coulomb. Then one thing should be noted: there are two spheres around a charge. Through both the spheres, total flux will be same, but per unit area, the flux will be different. Definitely, for smaller circle, the flux will be more per unit area. This is shown where EA cos theta. Theta is the angle between electric field and the area vector. Area vector is perpendicular to the plane, and smaller area should have smaller flux, smaller open area. Flux per unit area will be more for the smaller sphere. Now, what is theta? Theta is the angle between E vector and area vector as shown. Area vector is perpendicular to the surface as shown, and in uniform field, smaller open area is having less flux than the bigger one. Thank you.